He was able to utilize the facilities of the Westinghouse Lamp Laboratories in Bloomfield, New Jersey, to test his theories on transmutation. Using a quartz tube similar to this, he was able to take water vapor and, using specifically designed magnetic fields, cause that water vapor within the tube to be transmuted into either hydrogen, nitrogen, or oxygen.
There are some who believe the latter-day transmutation of the elements lies at the heart of what the media has termed cold fusion.
So we're quite confident that we are transmuting about 95% of the naturally radioactive thorium used in these low-energy nuclear reactors.
Hal Fox heads the Fusion Institute, where research continues into a process declared impossible by the priesthood of high-energy physics.
This is a new technology with tremendous potential, and our first objective in our laboratory work is to help to reduce the problems of cleanup of radioactive waste by developing systems that can reduce the radioactivity by transmutation of the radioactive elements, reduce the radioactivity on site without transporting those dangerous radioactivity across several states, and then trying to store them for 10,000 years in some mountain in Nevada or any other place.
We're looking to determine the actual cause of low-energy nuclear changes. This is referred to sometimes as transmutation or alchemy.
But whether the ancient alchemical dream of transmuting lead into gold becomes a reality or not, it is clear that in the crucible of modern science, a no less dramatic change in the way people think has already begun to appear.
Scientists have begun searching through old data and new data falling out of current research into such topics as cold fusion that indicate there may be molecular changes and atomic changes occurring which are not explainable by the normal or previously accepted theories and paradigms of physics.
Science has long known that when the energy at the core of the atom is released, the power is virtually infinite. In recent decades, the only artificial way of achieving that end has been fission, or the splitting of the nuclei in atoms, as in bombs or nuclear power plants. Unfortunately, fission produces more than energy. It produces deadly radiation byproducts. A more desirable way of unlocking the atom's energy would be fusion, as in the sun, which yields few harmful byproducts. The problem, this method apparently requires heat comparable to the sun. It's not an easy thing to achieve on Earth. For decades, the holy grail of today's high-energy physics establishment has been the achievement of hot fusion, like the sun. But on March 23, 1989, two scientists at the University of Utah announced that they had achieved cold fusion in a 1-quart mason jar filled with deuterium. A platinum wire and a 1-inch square sheet of palladium attached to a wire was then added to the jar. Instead of the usually expected electrolysis, the apparatus was producing excess heat, which could not be accounted for by any conventional theories. The Utah scientists believed the nuclei of the deuterium atoms were being forced close enough together to create another element, thereby releasing heat and energy. Inasmuch as the U.S. Department of Energy and the country's leading high-energy physicists had been spending billions to achieve hot fusion, the announcements from Dr. Stanley Pons and Martin Fleischmann caused a sensation, but not for long.
In the beginning, there was polite reaction to Pons and Fleischmann. There was skepticism. We don't really believe they can be doing this. But they weren't being attacked right away. There was a sort of a grace period of a few weeks to a month or two But then the knives came out. They were actually already out on day one, but they were just being sharpened.
Dr. Eugene Mallove served at Massachusetts Institute of Technology during the period of initial furor following the discoveries of so-called cold fusion. Today, he edits and publishes Infinite Energy magazine.
And what happened was more and more people all over the world began to do the experiment in laboratories everywhere, and people began to report positive results. Of course, there were also negative results reported. And at a certain point in the spring of 1989, the story became so large, it was the cover story of Time, Newsweek, and Businessweek in the United States. And therefore, the Department of Energy and the President of the United States felt, President Bush at that time, felt something had to be done. So they hired a panel, they formed a panel of experts, so-called experts, to review this. There were 22 scientists on that panel. And that panel came to a very rapid conclusion with only months that this was negative, no good results were coming out of it, it was nonsense, and the co-chairman of the panel, Dr. Huizenga, really wanted to get rid of it 100%. He wanted a 100% negative report. It was very negative, and effectively killed off interest by the official sector and certainly killed off funding. But cold fusion research never stopped. It's very big in Japan now, very big in Italy, very big in many laboratories in the United States where the work goes on and toward commercialization. And we now have reactors that are putting out on the order of 1,000 watts or more that are prototypes for bigger things yet to come.
Fortunately, due to Pons and Fleischmann, we do have a repeating experiment in the field of cold fusion. No matter what, cold fusion will never die as a field, regardless of which individuals fail to participate anymore. It will carry on because it repeats, and it puts it into the realm of science. Not too many people necessarily believe it all, but that's because they didn't do the experiments. But those that have researched it, very intelligent people researching it, finally discover that there's a real effect there, and that hooks their interest.
These people at MIT showed that it didn't work because they tried it and it didn't work. Well, actually, a negative experiment is never any proof. But what was really sad about it, as Dr. Mitchell Schwartz showed, they changed the data to make sure that it showed that it didn't work. And we published in Fusion Facts the paper by Dr. Schwartz about that. The same was true with work that had gone on in England in attacking cold fusion and also at California Institute of Technology. They actually got some small amount of excess heat and then either ignored it or changed their data.
This phenomenon is far more established in the kinds of evidence that have already been produced for it than many other phenomena that physicists talk about today that they accept and that the journalists accept. For example, when you have some announcement from a major nuclear facility with 400 names of authors on one paper saying, we now have found a new quark, okay, we've identified some subtle evidence for it, or we're nearly certain the evidence is there. The evidence for cold fusion is far, far, far better than that kind of evidence, okay? And furthermore, that kind of information, as wonderful as it is to know about the structure of subatomic particles, is nowhere near as important as our energy survival and the environmental welfare of the planet.
Humanity has always searched for energy, from the fire that warmed us in the caves to the animals that pulled our cars.